Having choices opens up possibilities. Whether in programming or in life, if we had to follow the exact same set of instructions all the time, we'd be pretty limited in what we could do. However, if it's possible to have choices, to sometimes do one thing and sometimes do another, we open up a much greater world of possibilities. In this lecture, we're going to see how we can make choices in our programs. We'll be learning about what we call conditionals, a way of saying, if this set of conditions is met, then do something or other. These choices will allow us to have much more interesting and varied programs. In order for us to have a conditional, though, we need a way of specifying what a condition is. And to specify what a condition is, we need a way of saying that a value can be either true or false. A variable we define as being true or false is called a Boolean. It's named for George Boole, who developed a way to simplify logic. We've seen that we can have variables of an integer type and variables of a floating point decimal type. Well, we can also have logic variables that are a Boolean type. In C++, we can declare these variables to be of type bool, that's B-O-O-L, with no E on the end, with a value of either true or false. In this example, we've created two Boolean variables, one called test_true that we initialize to the value true, and one called test_false that we initialize to the value false. Notice that true and false are defined keywords in C++. Now, although there are two keywords, true and false, C++ ultimately reads them as just the two possible values of a single bit. Let me show you what I mean by looking at what we get as output when our program runs. Remember, we're outputting the value of each of the two variables, one true and one false. The true value gets the output 1, and the false value a 0. What's going on here? Well, one way to think about this is that a Boolean variable can take on two values, true or false. In a computer, a bit can also have just two values, 1 or 0. So, once our code has been compiled into a set of machine instructions, those variables that we declared as Booleans could be stored in just one bit. And we'll use a 1 to represent true, and a 0 to represent false. So, anytime we want to say that something is false, we can just say that it's 0. And anytime that we want to say that something is true, we can just say that it's 1. There's no special true or false values, just 1 or 0. In fact, C++ interprets any value that's not 0 as true. Here, the Boolean variable test_true is assigned the value 2. But when we print this out, we see that the variable has the value 1, that is, true. Now what's happened here is that the computer is saying, well, 2 is not 0, so it must be true. It's converting from an integer to a Boolean, and any integer that's not 0 gets converted to a 1. So, Boolean variables are all about true and false, where 0 is false and any other integer is true. The operations that we can do on Boolean variables are also different. We don't add, subtract, multiply, or divide. Instead, for Booleans, we've got three main operations: and, or, not. These work just like what you might see in any logic course. Now the not operation is the simplest. Not just flips the Boolean value. True becomes false, false becomes true. It's just like when we talk. If we say something that's a false statement, like the moon is made of cheese, we turn it into a true statement by adding not. The moon is not made of cheese. In C++, we use an exclamation point to represent not. For example, exclamation point raining means not raining. Here we see two examples of the not operator being used. Notice that we put the exclamation point before the Boolean value that we want to take not of. In this case, we have two variables, raining being true and windy being false. If we take not raining and not windy, we'll get the opposite values for each one, that is, false and true. The next Boolean operation is and. And is used when we have two different Boolean values, say x and y. If we say x and y, then that statement is true if and only if both x and y are true. This is not addition. So if I say, my name is John, a true statement, and I live in Hawaii, a false statement, then putting them together, my name is John and I live in Hawaii, is overall a false statement. It's not enough for one to be true. True and false is false. They both have to be true for the overall statement to be true. We represent AND in C++ by a double ampersand. Now be careful to use two ampersands. If you use only one ampersand, that's what's known as a bitwise AND, and that's not what we want. Okay, suppose we have two Boolean variables, early to bed and early to rise, that we initialize to true. How do we create the AND operation? Right, with a double ampersand. We're going to assign this to a third Boolean variable, HWW. When we run this program and get to the first output statement, we'll see that the output is 1 and 1 is 1. In other words, true and true is true. Now, if we change the value of early to rise to false and recompute HWW, we're going to find that the output result is true and false, which is false. Likewise, if early to bed is false and early to rise is true, false and true is false. So we output 0 and 1 is 0. And finally, as expected, if both early to bed and early to rise are false, then false and false is still false. The third Boolean operation is OR. The OR operation again takes two Boolean values, but it's true if either one of the two is true. It's also true if both are true. So, saying, my name is John or I live in Hawaii is a true statement, since at least one part of that my name is John, is true. And it would still be true if both parts were true. If I said, my name is John or I live in Texas. In C++, we represent OR with two vertical bars. Now, we don't use the vertical bar very often in everyday typing, but you do use it here in C++ programming. You'll probably find that vertical bar character above the / key on the right of your keyboard, above the return or the enter key. Now, our two variables this time are chocolate syrup and chocolate ice cream, and we'll use those to create an output variable, chocolate sundae, formed by taking chocolate syrup or chocolate ice cream. That is, a sundae is a chocolate sundae if it has either chocolate syrup or chocolate ice cream, or both. Okay, so how do we make the OR representation? That's with two vertical bars. Our initial values are true for chocolate syrup and true for chocolate ice cream. A true value or a true value gives us a doubly true value. That is, 1 or 1 is 1. Chocolate syrup is true, chocolate ice cream is true, so chocolate sundae is most definitely true. Now, what if we have true or false? Right, we still get true. 1 or 0 is 1. And conversely, if we switch to false or true, we still get true. However, if chocolate syrup is false and chocolate ice cream is false, then we have false or false, which means we don't have a chocolate sundae. The whole statement is false. That is, 0 or 0 is 0. Our three basic Boolean operations, and, or, not, can be combined to make more complex logical operations. And there's an order of precedence in the way that these logical operations are evaluated. You know how in math you evaluate multiplication and division before addition and subtraction? Well, for these logical operators, your computer will evaluate not first, then and then or. Now you might remember this as the magical kingdom of Notandor. But people make mistakes all the time when writing logical operations because they forget this order. So you can avoid these mistakes by just specifying the order yourself with parentheses. Just to illustrate, take a look at this code. Both of these expressions are identical, and they evaluate to true. However, it's a little easier to follow the second one than the first. Really, there's no downside to putting in parentheses, so put them in to make sure your expressions are clear. In fact, you'll notice that even on the first line, I'm putting parentheses around the whole expression. Any guesses as to why? Well, if you leave those parentheses out, you'll find that you get an error when you try to compile. And that's because the stream operator, the double less than sign, takes precedence over the and or operators. So the code reads as though you're trying to output just not true on the first line, and then it encounters an OR that doesn't make any sense. The same thing happens on the second line. The compiler thinks that just the not true is being streamed, and so the OR that follows it makes no sense. So my suggestion, my strong suggestion, is that you always enclose your Boolean expressions in parentheses. That will make sure that you don't have any weird behavior due to order of operations. Let's just do a longer expression here to practice following the logical operators. Take a look at this expression, where I've put in a T for true and an F for false. Is this overall expression true or false? We can work through this expression from the innermost parentheses outward. For example, in the first step, we find that true and false is false. True or false is true. And twice we find that not false is true. At the next level of parentheses, we find that not true is false, and that true or true is true. At the next level, we have that false or false is false, and that true and true is true. And finally, we find that false and true is false. So the overall expression is false. Now, if you got through that, great. That was larger and more complicated than we'll have in normal situations. Okay, so far we've just been declaring the values of our Boolean variables, but that feels weird, almost like cheating. What we need instead are ways of determining whether a Boolean is true or false. One of the most common ways of doing this is with comparison operators. When we compare two values in C++, the result is a Boolean, either true or false. We're taking two different values and asking questions like, are these the same value? So that the result is either true or false. We can assign the result of the comparison to a Boolean variable, like writing the variable team1 winner gets the result of the comparison of team1 points greater than team2 points. Or we can use a comparison in a Boolean expression, like heart rate is greater than 100 or respiration is greater than 30. Let's take a closer look at a few of these comparisons by looking at some code examples. The code you see here shows several comparisons. We have two variables, team1 points and team2 points, initialized to some values, 17 and 20 in this case. We can compare to see if team1 points is less than team2 points using the less than sign. The answer is true, and the output will show a 1. The same is true if we use a less than or equal to comparison. We can also make a greater than comparison, or a greater than or equal to comparison. In this case, the answers will be false, since team1 points is not greater than or equal to team2 points. Comparisons are pretty straightforward, but there's one rule to be aware of. When you write greater than or equal to, or less than or equal to, you must always put the less than or greater than sign first, and the equal sign second. Writing equals less than or equals greater than are not okay. You'll get an error. Now, we can assign the results of comparison to a Boolean variable. In this snippet of code, you'll see that we have a water temperature variable. We then create Boolean variables. Is freezing is less than or equal to 32 degrees Fahrenheit. And is boiling is greater than or equal to 212. In this example, the temperature, 35.3, is neither. So both comparisons will return false, and thus both Boolean values are false. Now, besides less than or greater than comparisons, we often want to compare just to see if two things have the same value, or don't have the same value. And for this, we want the equality and the inequality operators. These require some double symbols, different than you might expect, so pay close attention here. To check whether two things are equal, we use a double equals sign. Why is that? Well, remember, a single equals sign is not saying equals, it's saying assign. When we write x equals 3, we're saying assign the value of 3 to x. If we want to compare, if we want to ask is x equal to 3, then we need to write the expression x equals 3. That expression will be true if x has the value 3 and false otherwise. To check for inequality, we can just use exclamation point equals. There's no not equal symbol on the keyboard, so instead we use exclamation point, meaning not, and the equal sign. Now this comparison operation means not equal to, so if we want to ask, is x not equal to 3, we would write x exclamation point equals 3. Now this expression will be false if x is equal to 3, or true if x is anything else. Let's look at a piece of code here just to illustrate. In this case, we create 3 integer variables, numFish, numCats, and numDogs, initialized to the values 1, 2, and 2. If we compare the variables numFish and numCats for equality, the answer we get is false. While if we compare for inequality, we'll get the answer true. Likewise, if we compare numCats and numDogs for equality, that will come out to be true, while comparing for inequality will be false. Let's look at a simple piece of code to show how equality operators might get used. Let's say that you're operating a business and you want to give a discount to anyone under 18 or 65 or older. After reading in an age, we can set a Boolean variable, eligible for discount, to be the result of a Boolean expression containing comparisons. We check to see if the age is less than 18 or the age is greater than or equal to 65. The line we write is, eligible for discount gets age less than 18 or age greater than or equal to 65. Of course, we put parentheses in our Boolean expression to make sure the order of evaluation is clear. So, this Boolean variable, eligible for discount, will be true if either of those is the case, and false otherwise. For example, for age 10, the program will return 1 for true. However, for age 45, we get a 0 for false. Now, as nice as Boolean values and expressions are on their own, their real power comes when they get put into conditional statements. A common term for a conditional statement is an if-then-else statement. Let's look at the basic form of the most simple form, the if-then statement. A conditional statement starts with the keyword if. Next, in parentheses, is a single Boolean value. There have to be parentheses. You can't just put a Boolean value there. Now, the Boolean value itself could come in a lot of ways. It could be a simple value like true or false. But the value is more likely to be given by a Boolean variable, or be given by a Boolean expression made up from comparisons and Boolean operations. Now, regardless of which way the Boolean value is specified, it needs to appear in parentheses. This Boolean is the condition of the conditional statement. Then, after the parentheses is the command to be followed if the Boolean value is true. That is, the command that follows the if statement only gets executed if that Boolean value in the parentheses evaluates to true. If there's just a single command to execute, then you can write that command just like any others. There are 3 common ways of writing this. It could be written right after the parentheses on the same line, or it could be written on the next line. And if this is done, it's common to indent the command a little bit. Anywhere from 2 to 4 spaces is common. Indenting is just a way of showing to people that the command only gets executed if the if statement is true. Another option, and probably the most common, is to put curly braces around the command. The computer does read the curly braces, and what they mean is that everything inside of the curly braces counts as the thing to do, if the Boolean is true. Now that way you can have lots of commands, not just one, executed when the Boolean is true. When doing this, it's again common to indent each of the commands that should be executed to show that they're only encountered when the Boolean is true. The closing of the curly braces is commonly put on a new line, not indented. Now, let me make a suggestion. Always put curly braces around the result of the if clause, even if there's only one command. If you leave off the curly braces and later add another command as part of the if statement, it's too easy to mess things up, to accidentally forget to add the curly braces. If you get in the habit of always using curly braces for the if clause, you won't run into nearly as many problems later on. Let's say that we wanted to determine whether someone had a discount, like we did before, and give them a message that they're eligible for the discount. We can do this with an if statement. we write if, parentheses, and our Boolean expression. It will be true if the age is less than 18 or greater than or equal to 65. Then we have our commands, starting with curly braces, and our output statement, you're eligible for a discount. If we run this program and enter a valid age, like 10 or 70, we'll get that message printed out. If we enter some other age, like 45, we won't. Now, what if we wanted to output something different whenever the person was not eligible for a discount? Well, this is where the full version of if-then-else comes in handy. By adding an else clause, we can extend the if statement to also state what command should be done if the Boolean value is false. Right after the command, or the set of commands in curly braces, that should be executed if the Boolean is true, we write the word else. Notice that the closing of the previous curly braces might be at the start of the else line. Anyway, after the else, we give the command we want to execute if the condition is false. If we want to execute more than one command, you again need to enclose them in curly braces. Just like before, it's helpful to indent to show which commands belong to which part of the statement. Your IDE will probably indent the right amount for you automatically, though sometimes if you write commands out of order, it won't. By indenting consistently, it'll be easy to see which command or commands are executed when the condition is true, and which are executed when it's false. And, as with then commands, I recommend getting in the habit of always using curly braces for the else statement. Let's go back to our example again, the one with the discount computation. We've now added an else clause, so we have an if-else statement, commonly called an if-then-else statement, even though we don't explicitly use the word then. The else clause will print out a message when the Boolean expression is false, such as, sorry, no discount is available. But our prices are so low you won't even notice. So, if we now run this code and enter an age that's eligible for a discount, we still get the original message. And if we enter an age that's not eligible, we get the new message instead. Notice that it's really easy to extend the case to do more than one command inside of the curly braces. We've modified the code here to have a new floating point variable, price. Price will store the cost for that person. If there's a discount, they'll get a price of just $5, while if they don't get a discount, the price will be $7.50. Regardless of which price is set, the cout command at the end will output the price that person would have to pay. So, if we run this, we'll see that those eligible for a discount do indeed get a lower price. Now, in that last set of code, notice that we ended up adding some additional lines into the set of commands as part of the then and else statements. Again, that's another example of why it's good to use curly braces to group your commands together, even if you think you only have one command. In this modified version of the same program, I've left off the curly braces following the else statement. What do you think will happen? Try it yourself. Well, if you ran the code, you should have found that even people who should have gotten a discount got a message meant for those who didn't, and that everyone received the same price, 7.5. Why did that happen? Well, when we get to the else statement, since there were no curly braces, only the first command after the else applied to the else clause. The other lines, the second cout and setting price to 7.5, will run for every situation. The fact that they're indented doesn't matter to the computer. They need to be in curly braces if they only apply to the else. Now this is the sort of mistake that happens easily, even to experienced programmers, when people aren't careful to put curly braces around their if clauses. Now, the commands you put in curly braces for a then clause or an else clause can be just about any commands. That includes more if statements. Let's look at some code used to calculate the shipping cost for a package. First, there's weight and there's type of shipping. So we have a couple of variables, a floating point package weight and a Boolean indicator of whether it's send priority shipping or not. In this case, we initialized package weight to 5 and send priority to true. As for cost, the system is that if there's priority shipping, then all packages weighing less than 3.5 have a fixed cost of 10, and otherwise the cost for priority is based on weight, while all of the non-priority packages just have a cheaper cost based on weight alone. So, our code for cost starts with an if statement to check whether the package is to be sent priority or not. There's also an else clause to handle situations when it's not priority. In the case where we have priority shipping, we have another if statement. This one checks if the package weight is below 3.5. If so, it sets a fixed cost of 10. Otherwise, it assigns a cost given by the weight times 3. Having one if statement inside of another is called nesting. We say that one if statement is nested inside of the other, since the other one surrounds it. It's even possible to have multiple levels of nesting. One if statement inside another, inside another, inside another, etc. Now, as for the case where we don't have priority shipping, this is where the else clause of the outermost if statement comes in. In this case, the cost is a lower rate of weight times 1.5. We should use nesting whenever the code we have makes natural sense to organize in that way, where you want to make one choice and then another. Now, there's one more way of writing if statements that I want to mention, because it's a common and useful way of writing conditionals. It's also one place where I actually do recommend breaking the suggestion to always use curly braces, but only in this particular setting. Let's say that we have some sort of tiered pricing system, similar to the one we discussed earlier, but we want kids under 3 to be free, those from 3 to 5 to cost $1, those from 6 to 10 cost $3, those 11 to 17 cost $5, and everyone else costs $6. Let's look at one way of organizing that. This code shows a bunch of nested if statements. We start by checking whether the age is less than 3. And if so, we set a cost of 0. Otherwise, we go to the else clause. In the else clause, we have another if statement, this time checking whether this age is less than or equal to 5. Again, we set a cost in that case, otherwise we go on to another else clause. And this continues until we handle all of the cases. Now, when you look at this code, you might have the reaction, that looks like a mess. And it does. All those nested statements are confusing, especially when our conditions aren't really that difficult. And this sort of comparison, where you have several values to assign for lots of similar cases, is not that uncommon. In these instances, it's helpful to remember that in C++, the spacing and line breaks don't actually matter. Thus, we can reorganize the indentation, tabs, and organization to make this a little more readable. First, notice that in this situation we have a series of else clauses, each of which contains just a single if statement. This is the one situation where I'll recommend not using curly braces and not indenting the if statement. If we get rid of the curly braces when there's just another if statement inside, and we move that if up to the previous line, let's see what the code looks like. Doesn't that look a lot cleaner and easier to read? Notice that we still have the else-if combinations just like before, but we organize it in a way that makes it much easier to see the different cases and what to do in each one. We can read down the list of conditionals: age less than 3, age less than or equal to 5, age less than or equal to 10, age less than or equal to 17, and find the first one that evaluates to true. Or, if none evaluate to true, then we have a final else clause. Although this code works exactly the same as the previous code, it's a whole lot easier to follow. We'll call this way of organizing the code an else-if structure, and it's a good idea to use it in cases like this, where you want to select one of several related options. Conditionals let us make programs that can choose which action to take depending on the situation. The simple fact is, if you want to write more interesting programs, then conditionals will form a key part of most of your programs going forward. In the next lecture, we'll start thinking more carefully about the process we should go through when we want to create our own programs. See you then.